Hi everybody, and thank you. And thank you all for still being here in the last session of the day. I hope you've all had a great day so far. So this last session is actually going to be a customer story, and I always like it best when a customer is telling other customers about their journey and about the results that they've got. Greg Van Gaans is from the Department of Planning, Transport and Infrastructure in South Australia. Greg actually leads the geospatial practice there, and they're an agency that actually has a much broader geospatial responsibility than in many states, because in many states it's divided amongst different agencies. It's quite a broad portfolio that he's responsible for. And over the last couple of years, they've migrated quite a number of workloads from on-prem kit onto AWS. And Greg is going to talk about that migration, but the amazing thing about the work that he's done in the last couple of years is that rather than just build a stack of stuff running on AWS, they built it in such a way that there are now 18 other government agencies using the same AWS infrastructure. So they've done it in a way that's templatable and repeatable, so that it's a fairly trivial matter to have an extra agency using the same stack. And so this is the kind of thing that obviously was not necessarily possible in a world of silos and on-prem kit. It's something that's close to my heart as a member of the Public Sector Solutions Architecture team, to try and get agencies around Australia to collaborate more and to do less of the sort of repeat heavy lifting that we tend to do around the country for, solving essentially the same problems. So please help me welcome Greg to the stage.
Hi everyone, welcome and thank you. Thank you for the opportunity to speak, I appreciate it, Herm. I don't like the term shared service. What we're going to talk about is not a shared service. It's a collaboration of the willing. So it's not a mandated thing that people must adopt. We've had some shared services disasters in South Australia. This is not one of those. So what I'm going to talk about is Location SA's AWS journey. So Location SA is a group of government agencies that willingly and collaboratively want to adopt the services that we provide. The agency that I work for, DPTI, the Department of Planning, Transport and Infrastructure, is the lead technical agency for the rest of government. And there are several reasons why we do that. One is, I don't know about you people, does anyone here geospatial people? A few, a couple? Okay. So what we're finding in South Australia is that we can't attract good quality geospatial people to the state. And it's getting harder and harder and harder to find resources. It's a bit like having experts in machine learning or AI or data scientists. They're getting harder and harder to get and more expensive. So by consolidating our resources and by consolidating our efforts, we've been able to A, keep the lights on, and B, deliver some, what I think are pretty awesome services for the South Australian government. So what you're seeing on the screen there is what we deliver. And there are 3 tiers of delivery that we do. There is a foundation tier. So the foundation tier is really about automated data sharing across the public service. What we did find was that we had agencies copying data from one agency to another. In a star topology, there was replication of data going uncontrolled agency to agency. Then what we discovered was even worse. We had people value adding to that data. So then where's the source of truth? It even got worse than that. We had one agency take our data from DPTI, for example, the cadastral data, value add to it, and then sell it. So we were the custodian of the data, we were doing all the data maintenance, the other agency was selling it and getting the revenue. So, this is just bad behaviour. So we tried to address this by having a spoke and hub topology, where the data is written to a single point of truth, a single warehouse, and then disseminated out to the other agencies. That's where we started. On top of that, though, there is now a Location SA data catalogue, which is a metadata catalogue. So every data set within Location SA has metadata. It's all IRAP certified. It is, we think, high quality, the best data that we can get from an agency for dissemination to other agencies. We also, and there's over 500 plus data sets in that repository. We also have a map viewer, which is the Location SA map viewer. So if you want to Google that at some stage, just Google Location SA map viewer and you'll be able to see it. We present about 267 layers to the public. And that application, we underestimated just how popular that would be. And the main reason why it's so popular is it has a share function. You can go to the screen, you can put some text or a marker on that screen, you can go share, put it through to Facebook or to Twitter or to an email account and share it with other people. So a lot of agencies and a lot of the people in the public are using this to do things like workforce planning. They're going, your job today, Joe, in your van is over here. And they, it's a use case that we didn't even see coming. We provide a whole lot of other things. We provide national address validation, reverse geocoding, forward geocoding, street map web services, intersection services, so putting a pin through various layers and returning information about those layers, including standard ABS layers. So you can drop a pin, it'll tell you what postcode, what suburb, what SA1, SA2, mesh block, etc. We have land data services, which are land ownership and tenure, sales price, who owns the land, those sorts of things, and obviously they're restricted. And we also have a location, say, program officer. And that office basically coordinates the government's geospatial efforts. It does the vendor licence management, so we manage our ESRI enterprise agreement out of that licence. It is a practitioner community, and it is really where you can, if you're in government, you come to get professional geospatial advice. So that's our foundation. We charge an agency $20,000 for that privilege. Okay, so I'll talk about the pricing as well. It's not secret information. So the solution level is the next level up, and this is where Amazon became involved. We deliver a hosted platform as a service for government agencies on Amazon infrastructure and using Amazon Web Services. The solution level is software as a service, and it's really designed for agencies that aren't geospatial professionals but want to go do something with a piece of geospatial software, like go out into the field and do a survey. Department of Education might want to go to a school and say, we want to go and survey these schools and find out something about the students at that school. So a solution is something which we custom configure on the ESRI technology stack that's sitting on Amazon Web Services, and we configure those applications and send them out. It sounds expensive. They're $30,000, and the reason why they're expensive is because of the amount of human capital that we have to put into those applications to build them, even though they're configured. They're not bespoke built. The last tier, which includes all foundation services, is the enterprise stack, and that really is platform as a service. So we have 7 agencies using platform as a service. We give them the keys to the kingdom to an enterprise portal, so ArcGIS Enterprise portal. They log on to that portal, they configure their own web apps, their own applications, their own maps, so on and so forth, and run that within their agency. So they never see the Amazon back end. DPTI, our lead agency, runs that on their behalf. They simply see the ESRI software as a platform. That's where we are today. So it's a fairly advanced offering today, but what I really want to talk about is the journey. Why did we first look at Amazon? Well, we faced, purely through coincidence, that we faced 2 problems at the same time. One was that our high-end GIS infrastructure was end of life and needed replacement. So that server infrastructure, when I say high-end, would cost us about $400,000, $500,000 to replace today. These things had 768 gig of memory, 128 cores. They're connected to high-speed SAN through fibre connections, SSD on the SAN. This is not cheap kit to replace. So we went, okay, it's end of life, we need to replace it. But at the same time, that same kit was failing to complete a really important geospatial task, and in a reasonable time frame. So that task was building raster base maps. Our satellite imagery and our aerial photography mosaic, a topographic base map, which is really what the emergency services use. We call it the CFS map books. It's basically all the topo data. It has contours, homestead locations, watering points like dams where fire trucks will go and fill up if there's in an emergency. And the third one, which is a Google-style street base map. Building one of those base maps, which was the topo base map, was a big problem. It has in it, I'll just get my facts straight, it has in it 440 layers of information and is built down to 21 levels of detail. So when you're building base maps, what you'll notice in the previous slide is, if I give my pointer. So every time you add a level of detail, the next level of detail is the square of the layer before it. So here we have 4 tiles. The next layer is going to be 16 tiles. If you keep doing that, the next layer will be 256, the next layer will have 65,536, the next layer will have 4.2 billion, the next layer will have 1.8 by 10 to the 19 tiles. And if that's only down to level 7, we're going to level 21. It is trillions of tiles. So to build those tiles is a time-consuming exercise. So our topo base map was taking 56 hours, 440 layers of information being ripped out into many, many, many tiles. It just wasn't going to work for us. So this is when we started talking to Amazon. And so AWS said to us, why don't you go and try EC2? It's a really, really simple thing. It's not going to cost you the earth. I'm not sure about that. He goes, no, this is Ivor from WA, my account manager, said, no, it won't cost you the earth. In fact, I'll give you $100 worth of credits. And I laughed at him. I said, $100? I'm not going to build anything for $100. I'll give you $1,000. Okay, give me $1,000. Anyway, so we went and on our own, without seeking any advice from AWS, we went and chose a server. So it took, at the end of the day, you'll notice it's got one availability zone, so there's no high availability, and there's no auto scaling to roll out some bigger servers. So what we probably did from memory is we chose probably a GPU-enabled server, the biggest one we could find in the stack. Looking at that, 32 hours at $500. It was probably a fairly high-end GPU-enabled server costing about $10 an hour, a bit more, $15 an hour. And to our surprise, it completed the task in 32 hours, and Ivor was right, the price was $500. And we went, wow, problem solved. We'll go to the next slide. Ivor said, no, you babes in the woods, you just don't understand. So at that point, we went and leveraged the solution architect from AWS. How much do you think that cost me? $0. When you engage with Amazon, it's in their interest to give you an architecture which works, and it's in your interest to get an architecture that works. So we spoke with the Amazon architect, and basically they came up with a new architecture which included auto scaling, and they said start off with a small server, and then as the load ramps up, it will auto scale out. They also opened our eyes to things called spot instances. And spot instances are very, very cheap. They're underutilised capacity that is then sold to the market at a very, very cheap price. So you can get really, really high-end servers for a really, really low cost. We took Ivor's advice and the architect's advice, and we did that, and we got the build down to 14 hours at under $150. Now that's just amazing, right? So we do this weekly. That's just cheap as chips. I'm not going to go now and buy $500,000 servers. It's just not going to happen. So it was really, really good. And that was our first journey. The other thing which I'll say about this, though, was the whole thing has been templated into CloudFormation templates. And because it's in a CloudFormation template, it means that there's no DCSS on those servers. We don't have to manage the servers. We run the CloudFormation template, so there's no servers. It installs the software, stands up the server, goes to the market, grabs the spot instances, configures them, runs the job, and then when the job's finished, terminates all those servers, and they're no longer around. Amazon have a saying that you treat your servers like cattle, not like pets. You don't keep them around, you don't pet them, you don't inoculate them, you don't look after them. They're livestock, they're temporary. So that's what you do. You stand them up, you run the job, you kill the server, and it's finished. And that works for us. Fully automated. No, we don't have to worry about our DCSS provider coming in and making sure that the servers are patched and everything else. So that was pretty cool. Those base maps underpin a thing called the Location SA Map Viewer, and this is just a screenshot of that map viewer. You'll see the URL up there, location.sa.gov.au/viewer. Have a play around with it. There are 256 layers of public information on there. But the maps that I was talking about in that discussion just then are these base maps. So you'll go to maps, and under the maps tab there are 3 styles of base map: the topo, the street map style, and the aerial photography. The aerial photography is down to a resolution of 7 centimetres. We don't let that out to the public at that resolution on this application because of licensing constraints with our provider. It's a little bit too good. So we go to about 30 centimetres, I think, on that public page. All right. So what were our next steps on AWS? So we were hooked at that point. That was it for us. We said, yeah, we're doing this. And so the next thing we did was as Ivor pointed out to us, was that we really were quite naive in our understanding of cloud and how cloud should be set up. So we paid for a thing called an Enterprise Jumpstart with AWS ProServe, and that was worth every cent. I'm just going to check my notes here so I make sure I don't miss. There's some important things here. So what ProServe gave us was an efficient organisational account structure so that our servers were actively managed, used, reported, and the costs minimised. But also, and Ben Potter, who's in the room up here, he's a security expert, global security expert for AWS. I was fortunate enough, he's an Adelaide boy and he was in town, so he helped us out. So our Jumpstart was very security-centric, and that's turned out really well for us. So it meant that our Jumpstart established an environment that met AWS's best practices, but also South Australian government best practices. So for anyone to get onto our Amazon platform, you must use multi-factor authentication. It's at least privilege access. The data is encrypted at rest and in transit. There are auditable transaction logs, secured servers, VPCs, ports, and everything else. Now, if we had to try to unravel that ourselves, we conservatively estimate that that would have taken us 18 months, and it would have taken us, we would have made myriads of mistakes along the way, even to the point where we may have exposed some data and services unsecurely to the public connected, to the internet connected VPCs. So it was money well invested. 18 months, that was pretty saving, we think. Okay, so I'll talk a little bit more about where Location SA is today on AWS. I'm just keeping on the time because I'm also aware that I'm between you and your beer at this point in time, so I won't go over. So we have fully embraced AWS Cloud. We've moved away from traditional application management on physical infrastructure. We don't talk about the traditional 3-tiered architecture, your data tier, your business logic tier, your presentation tier. Well, that pattern is still relevant. We don't talk about it in the terms of physical infrastructure. Instead, what we've tried to do is to fully embrace AWS Cloud by reducing our dependency on infrastructure at all. We don't want to be reliant on EC2 servers. We want to adopt a broader range of serverless offerings and let AWS worry about running those servers. Our job is delivering geospatial data to our clients, whether that be government or the public. It's not and shouldn't be about running infrastructure, about running those servers, patching servers, making sure the server's going to scale, making sure that the services and the software are performing properly. So we are now at a different level of maturity where we're not so much looking at EC2 servers, we are looking at what serverless offerings we can adopt from AWS. This is just an example, standard architecture you can pick up on the AWS website that shows you a good example of a weather application using serverless. So what that's done for us is it's led to a significant reduction in maintenance for us because we don't have to manage servers. We have more manageable applications because by using serverless, we've been able to break applications down to microservices, decoupling them from the application. So if we have a failure or something goes wrong, the only thing we lose is that one microservice. The whole application doesn't fall over, but one small amount of functionality may fail. By leveraging serverless, we also have better performance because these things are largely global services, which means they scale. You don't have to worry about the HA aspect of it. They will scale automatically. So S3 is an example, Lambda is an example. These things scale automatically. You don't have to worry about the capacity. There is better security and protection because those services are protected. And there's improved reliability because they're highly redundant across multiple AZs within the region, which helps as well. So today we're adopting quite a few more services than we did when we started. We started out looking at a single elastic compute service up there. And now this is a subset of services which we use. It's about 25 there. We're up to about 30 services. You might think that costs a bomb. It doesn't. I'll talk about that a little bit more in a minute. I'm going to talk about Lambda. Lambda deserves a special mention. Its function as a service. It's a versatile, cost-effective way of implementing functions or microservices. The one thing that we've realised about Lambda and about doing this in the AWS ecosystem is that it's brought our developers together. We've got Python developers, JavaScript developers who use Node.js, and C# developers who are using .NET Core, all on Lambda, all on AWS. So now the discussion's around implementing the functions, and that means that the developers are actually communicating and talking to one another, and it's not about the language or about whether it should be Python or whether it should be JavaScript or whether it should be C#. The first thing is, what is the business requirement that this service is going to meet and fix? The argument about the language and what's the best fit comes secondarily. As I said, Lambda can be used to deliver microservices. DPTI uses Lambda and a thing called kube.js, which is an Esri community tool to deliver feature services on traffic congestion. So if you want to have a look at that, you can go to traffic.sa.gov.au. I'll try to see if this works. And if we can we flick across to... If it doesn't, yes it does, there we go. So this is live, this is Adelaide now. If you're living in Sydney and Melbourne, you're probably going, wow, traffic congestion. So there's a bit, we've got some. We've got a 5-minute delay on Green Hill Road, and it looks like there's a bit up here with a bit of roadworks, maybe. What's this yellow one here? 3-minute delay there. So this is coming live, it's all run out of Lambda. There's no service driving this. It's simply a Lambda service sitting behind API gateway, which then delivers this through an API as a REST service to the client. The client's sitting in an S3 bucket, so there's no server behind that either. So the whole thing's serverless. Okay, can I go back to the slides? Thanks. That traffic delay information is captured by a thing called AdInsight, and AdInsight is an IoT thing. We have Bluetooth beacons at every major road intersection. As a car drives through that intersection, it picks up the hands-free kit in the vehicle, it gets an address from that hands-free kit in that vehicle, and then holds onto that. If that address reappears down the road at the next intersection, the timing's worked out between the time it first appeared and appeared the second time, and then that's compared to normal traffic volume and speed, and if it's out of whack, then it's a delay. Either that or it's a car speeding. Check out the costs. $0 for the first 1 million requests and 20 cents for every 1 million requests after that. We run that traffic congestion information on Traffic SA for about $6 a month. Why wouldn't you do it? You know, no service to worry. You know, highly reliable, highly durable services. You'd be nuts to not do it. So now let's focus back on, I've got 5 minutes, so I'll focus back on what we do use EC2 instances for, and that is to support our emergency services. So this is new. This has only been able to come about because of what we are doing on Amazon Web Services. Brand new as of July 1st. So providing platform as a service is something new. We thought it might be popular. We went from 0 to 7 agencies, 7 new agencies since July. That's like, because there is obviously an appetite for this software as a platform. So ArcGIS Enterprise Portals is what we provide under a high availability scenario. So again, an architecture, we worked with AWS to come up with an architecture You'll notice that it's got a couple of things which is important. It's auto-scaling. Auto-scaling. So as load comes on, the servers will scale. Load balancers, internet gateways, fine. The other thing you'll notice is that it's across multiple availability zones. So that if we lose a data centre, one of the AWS availability zone data centres, multiple data centres, I'm not sure, then we know that it's not going to drop because there's other availability zones behind us. By also adopting enterprise support with Amazon, we're obligated to do that from the emergency services perspective. If we're going to manage stuff, we have to adopt enterprise support. But it does a couple of other things. It gives us an incident event management, which means that if it's a 40-degree day with a 40-knot wind blowing, we can go to AWS and pre-warn them that we think there might be an incident the following day. Their response to that is they'll make sure they have bums in seats to cater for that incident. Right? They'll preload, pre-warm servers, make sure there's staff on deck in case something goes wrong, notify their security team that if there's an influx of traffic, that it's not a denial of service attack. Okay? It is actually something real. The other thing, though, which it's given us a dedicated technical account manager. And this is a person who comes on site. And while the emergency services agencies probably think that the IAM's the key thing, for us, what we've discovered, the real value of enterprise support is actually having a TAM in place. It is a fantastic service. It is really, really good. Helps us in so many ways, and they're not necessarily a specialist in one line. They're very much a generalist, but they have a lot of knowledge, and they'll point you to the resource within AWS to help you. They also help you manage your accounts and your costs. And so one of the big benefits we've seen is cost optimisation from TAM. Our TAM comes to us and says, do you know that you're underutilising EBS? Do you know that your EC2 instances are too big, you should make them smaller? One thing about that is with these location SA applications, we do over 30 million transactions, web REST requests on that per month. We noticed that the server sizing from our TAM said it's too big, and we were going, why is this? This is not making sense. We then realised that by adopting CloudFront at the edge, that most of the stuff was cached and was never even coming back to the server to put load on it. So another AWS service called CloudFront is a great way of taking load off of your EC2 service, which saves you money. Sorry. So where to from here? We've got 2 minutes. We currently have another jumpstart going on with Amazon, and that is really about now moving our DPTI lines of business applications out to cloud. So we're establishing a direct connect, which means that it's an enclave of our private state network into the Sydney region. That will allow us to get rid of some of our databases, which costs us a lot of money. We are on a bit of an open source journey at the moment, and we've found that Postgres has been not only incredibly reliable, but incredibly performant. It's been really, really good. We're re-architecting our DMZE because that's been one of our biggest banes and biggest points of failure. So by doing VPC peering, we can get from our internet connected cloud to our private cloud. There's a whole architecture behind that which AWS is doing for us at the moment because it's got to go through our security and government security people, obviously, to get that signed off. So that's probably all I need to say about that. The other thing we are doing is, the issue we found from a GIS perspective is that we've moved all the data up to cloud, and all of our desktop clients are still on our, what we call StateNet. And those clients don't work particularly well when the data is remote. They're very, very chatty, so they want to, if you put a terabyte up there, they probably want to drag a terabyte back down. So they're chatty, and that's really not a very smart thing to do because you start paying some fairly large data egress costs. So the other thing is our data analysts always say that they want high-end, big, powerful workstations, and then you get them, pull them, and half the time they don't use them, or vice versa. They try to run a big job on a standard SOE PC, and it locks up and just sits there at 100% CPU doing nothing, and they walk away and go, well, my PC's busy, I'll go do something else. It's not a good use of human capital. So AppStream is a thing where you can run an application in a browser. We're trialling ArcGIS Pro within AppStream 2. It means that your high-end, your Workstation compute is located close to your data, so they're both in the AWS data centres, which means that the network connectivity is fast. It means you can also go and stand up a very performant GPU-enabled workstation at relatively small cost and only pay for it while you're running the GIS job that you're running. So we think this has a lot of savings for us and avoids the problems with performance. And that's it, thank you, and I'm right on the money.